I think I might have accidentally enabled shush. No, I turned it off on my own. Oops. Okay. Now we've got sound back, so sorry that there was no sound. I was just explaining how we were getting this thing set up, but it didn't really matter that much. Just VirtIO, we're using VirtIO for the networking. The public LAN, the WAN is going to be VLAN 10. I actually do need to go over... The way that we're going to get this started is... Let's see, can I get this set up here? I'm actually going to have the WAN be coming from my router. So it's going to be double natted for a bit, just for me to get things bootstrapped and set up. So let me go back. I'm looking at another tab where I've got my networking stuff, and I'm just going to make sure that for VLAN 10, where did that go? I don't actually see that in here, but we should. Okay, create new network. Network name. I'm going to call it OPNsense WAN, and we are going to give it 192.168.2.1. Just kind of leave everything on auto, I think. Oh no, we need the VLAN to be 10. It's a standard network. We're not going to allow multicast across this one. We are going to have our DHCP server. Okay. Okay, so now, when this thing starts up, it should be able to get an address. Alright, so login needs to be installer. And then the password, I believe, is OPNsense. Yeah. Okay, let's see if we can get this popped out. So, there we go. Oh, I don't want it that full screen. I want it a little less full screen. Scaling mode off. Good enough. Alright, I'm not really sure what to... I guess this is the way to go, is we'll just put scaling mode, scaling off. That'll be good enough. Now, I can't see the chat, unfortunately. But, continue with default key map, yes. Yeah, we're just going to use the Unix file system. We're going to use the first disk that's 60 gigabytes, yes. Do we want to create a recommended swap partition? I'm not sure about that. I'll go with... Generally speaking, on VMs, we don't want to create swap. There are rare occasions when we do. I'll go ahead and allow it because it's the recommended. I'm sure that we can turn it off. You're going to destroy this. Are you sure? Yes. Okay. And then while that's doing, let me get back. And let's see. Well, while that's doing that, I do need to add more network devices. So we're going to need to add another network device, same VMBR, and this VLAN tag is going to be 160. Again, we're not going to have a firewall on this. This is going to be VirtIO, and I don't think that there's anything else about this. The VLANs are arbitrary, but I've got some documentation mapping what's what. So basically, I have a managed switch, and I have a VLAN that's specified to a port that I'm going to plug in the internet connection once I get everything set up, and I'm kind of bootstrapping at this point. So I'm using the existing router to bootstrap. But anyway, So VLAN 10 is the WAN, the internet, the actual the internet service provider is getting plugged into a port that is an access port for VLAN 10, meaning that my ISP doesn't know how my VLANs are set up or anything like that. I just plug the port in, and the managed switch behaves as though it's its own network. And then same thing here. 160 is the number that I'm using for the management IP range. And then there's also going to be, I think, this one I can say no VLAN. We're also going to have this vert.io. But the third one is going to be, the VLANs are going to be set up in FreeBSD itself, or in OPNsense itself. So again, this looks good. So this one is going to have full range to whatever VMBR has access to. What's up? I'm Brandon. Sorry, I didn't catch that. Let me swap over here real quick. Whoops. I had the wrong chat up here. There we go. Now I see it. So thanks for that. Appreciated. Okay. So now, oh, and like I was saying, the reason that this one is not VLAN tagged is that it's going to be, we're going to set up a lot of interfaces, one per virtual machine essentially, or not one per virtual machine, but one per virtual machine group or a container group. And so this interface, we're going to do the VLANs inside of OPNsense, but to make things a little bit easier, we're going to get these started with raw interfaces, so it's easier to have it work kind of out of the box. So let's go back to the console. This might be done installing and ready to be configured. Not quite. Oh, cloning current system 100%. Overall progress 80%. Verifying resulting files. Okay, so it's just doing some verification. So when this reboots, it should have all those network interfaces. And then I can just quickly set one as WAN and one as LAN and go from there. What I don't know how to do is how to get communication on the opt networks, which we're going to be creating with VLANs. So I am going to just search that real quick. Okay. Oh, I'll do that. So one thing that's kind of annoying is if you search for OPNsense, you literally get PFSense instead, because it's doing this, and this is true with, I think, most of the search engines. It's almost like it detects OPNsense as a misspelling of PFSense in a lot of cases. Okay. All right, change the root password. Sure, let's do that. I'm going to mute myself for a second. And then we're going to come back here. And I was expecting it would pop up. There we go. Complete install. Exit and reboot. And so with this, we should now also be able to just take out the CD. Say do not use any media. Okay. And let's go back to the console. There we go. I'm going to skip this song. It's weird. All right, maybe energetic is not really the way to go tonight. Let me go back to orchestral. We're doing overclock remix. Wait, what did it say? So, assign interfaces. I guess it expects VTNet 0 to be the WAN. So maybe I could... Do I want to set up lags now? No, I don't want to do that. Do I set up VLANs now? Sure. VTNet 2. And then we're going to give this one 170. And then VTNet 2. And we're going to give this one 1101. Or just 1100. And then VTNet 2, 1101. And nothing. Okay, now we're finished. Enter WAN interface VTNet 0. I would like to know what the what's customary for this, so that I could set it up. Enter LAN VTNet 1 VTNet 2 underscore VLAN 170 VTNet 2 underscore VLAN 1100 VTNet 2 underscore underscore VLAN 1101. Alright, and then we're done. Yes, we do want to proceed. It takes forever to configure the WAN interface for some reason. And then it doesn't even work, and then we have to go around and set it up a second time. Alright, so that's going to take a minute. Alright. Hey, this is the same setup that I'm trying to do. Okay. I'm going to skip this one too. So, looking for something that's not so vampire-y, you know? And hold on a second. I also don't want voices. Okay. So, set interface IP addresses. Let's start with WAN. Do we want to use DHCP? Yes. Do we want to do DHCP 6? No. Enter the new address. No, I don't want that. No. 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 All right. One thing I may need to check on is it might be... let's see if I can find my passwords here. No. I wasn't thinking about this. But it may be that the WAN interface isn't actually connected all the way through across. Let's see. Do I have... Let me check my VLAN tab. Okay, VLAN. Does it say that it got DHCP? When looks like that did not work. So I'm gonna check some things to make sure that WAN did go all the way through, and it looks like it's set there. Okay, good. I'm just checking my switches real quick to make sure that they are each configured. Oops. To trunk VLAN 10. Alright, that one looks like it is as well. Okay. But that one shouldn't matter because this is running off of just that one. Okay. Let me look at the access ports here. No access port for 10 there. That makes sense. And we do have an access port for 10 here. Okay. So in theory, this should have worked. So I'm going to try this again. Maybe I'll just reboot it and have it try again. Okay, those. All right, that should be trunking directly. Oh, let me make sure. Okay, too hardcore, too hardcore. Let's calm down. There we go. Now let me go back to the port manager and make sure this port is also tagged for 10, because that might be the port that goes bigger on is there. Okay. Manage port profiles. Switch ports, OPNsense WAN. And okay, apply changes. All right, let's try this again. Because apparently I added the network that's pretending to be the WAN, but I did not add it to one of the ports, because previously I actually had the internet connected directly. I had an Ethernet cable that is connected to the internet, plugged in to a VLAN 10 access port. And so it worked that way. But now, because I need to have a little bit more resiliency as I get things bootstrapped, especially if I'm going to be streaming while I'm doing this, I need to make that one layer removed. So the router is providing the networking to the OPNsense virtual machine. Anyway, what's up, chat? How are y'all doing? Okay, let's try this again. Option 2, 5. Do I want it to do DHCP? Yes. And then no. And then nothing. And then no, no, no. Alright. That little went a little quicker. For some reason, I just got logged out of the Restream chat. I have to click on pictures of bicycles. I hate this. Why do I have to click on so many pictures of bicycles? Okay, now I'm logged back in. Okay, cool. So that worked. 192.168.2.228. Cool. Kind of a interesting number that got picked there, but whatever. And then LAN. We need the LAN to be different. The LAN... Okay. Set interface IP address. We're going to go to LAN this time. Do we want it to be via DHCP? We're actually going to go... Yeah, we're going to stick with no on that. And then it's going to be 172 dot... Whoops. Dot 16 dot... 0 dot... I'm going to go with 5 for now. Eventually this should be 1. Actually, let me see if the other network's already set up this way. I think the other router is already .2 in preparation for this to assume .1 status. So let me go check that real quick. That is the management network. Yes. So this one actually will be .1. So 172.16.1. And this is on the one that's pre-tagged as 160. So there we go. And the mask is going to be 24. That's correct. And then for WAN, enter the new LAN IPv4 stream. For a LAN, press enter. I'm a little confused by that. Oh, right. Configure IPv6. No, we're not going to do IPv6 on this at this time. Do you want to enable DHCP server? Not yet. Do I want to change anything? No, no, no. All right, so... Oops. Here's what we want to see. Can we get to 172.16.1? All right. And the answer appears to be no. My question is why? So what I'm going to do is I'm going to try this directly from the system that this is on. So this is on PVE3. So let me get logged into PVE3. Okay, and then interesting. Seems like that's what it should have been before. Let me just refresh this. Get back. Okay, there we go. So, all right, what's the question? The question is, can I ping it directly from the server that it's hosted on? Okay, so that's problematic. Okay, well, let's see. So we're logged into this. Let's do a ping host. And let's try 1.1.1.1. Let's see, do we have internet access? It looks like yes, we do. Okay. So then let's try ping host. Let's try 172.16.0.2. Okay, that's not working out. So let me think on that for a second. Let's try picking another host. 172. Oops. Dots 16.0 dot. Can it ping itself? Okay. It can ping itself. Can it ping its guest or its host? No, it cannot. All right, so what might be going on here with the networking hardware? The tag is 160. Wonder what happens. I wonder if it can only paravirtualize on one of these at a time or something like that. Just for giggles, I'm going to change the underlying device. Probably shouldn't do that yet, though. Let's leave it like that for a second. Yeah, that's what I thought might happen. Okay, so let's just have this thing reboot. And let's just make sure everything's right on the host. So in our interfaces file, there's actually two interfaces that have 172, 116. Let's take the second one down for a bit. Let's look at this. That looks good. How about we make this from 170? No, we can keep the whole thing actually. right, that's its own management interface. So I do wonder about this right here. This could be the reason that it's not working, is that VLAN 160 is already being used by this interface. I wonder... That actually would make a lot of sense to me. If the way that this needs to be... Actually, let me go ahead and keep that. We might need to create VMBR0.160 here, rather than Eno.160. Just because of the whole master-slave nature of it. If 160 is already taken by Eno, then it may not be available to be taken by this. I might need to try something slightly different. I may switch which VLAN it's connected through just to kind of test this and see if it's working out the way that I'm thinking or not. We may need to put this on a different address. This stuff gets confusing. It's not clear on, it's not intuitively obvious to the most casual observer how this stuff is going to work out. So let me go ahead and let's restart networking on this. There's a good chance that it won't reconnect. Because it matters whether you do, because you can do the Linux interface, and you can do the VLAN, and you can do the bridge, and you can do a VLAN on a bridge. So, but some combinations are allowed and some combinations are not allowed, and they typically don't generate errors either way. So the way that I was doing it, we have this device assigned to the bridge. So that may not allow us to put the VLANs directly on the master interface, or I guess this becomes a slave interface. So Eno1, I believe, is a slave to VMBR0, and so once we've declared it a slave to VMBR0, yeah, we might have to do this. We'll see. We'll see what happens. I might even have that reboot once again. Let's have it reboot once more. So shut down. Let's say, okay, go ahead and reboot again. And if it still doesn't work, then I'm going to change the tag. Oh, you know what? Maybe this should completely shut down. All right, shut down. Let's bring it back up. So if this still doesn't work, I'm going to change the VLAN tag to try to isolate whether or not it's the VLAN is the problem. Hey, what's up, chat? How's it going? Let's see. think I can boot it up again. We will see. OPNsense, Proxmox, VLAN. This is all... Okay, this is what I needed to see. Is this... I think this is what it looks like in OPNsense. Oh, this is doing the VLANs only in this side. Okay. Yep. So VMBR. VMBR. Right. Okay. All right, let's see what happens here. Whoops. All right, that still looks good. So let's try pinging a host again. Let's try again 172.16.0.2. Hey, that worked. All right, cool. So my guess is that now if I refresh this, yeah, there we go. Okay, cool. So that was my problem then. My problem was simply that once you've declared one of the E devices, whether it's Eno or ETH or ESP or whatever it is, once you've declared one of these devices as a slave to a bridge, you cannot do VLANs on that device directly unless that VLAN is not slavable by the bridge. So before it was Eno.160, now it's VMBR.160, now we can get in. All right, cool, cleared up that. That's something that I really want to get documented. In fact, I'm going to go make a little note to myself right now in Bliss, my notes platform. And let's see. Okay, do I have any OPNsense? OPNsense. Okay. Once star is made a slave of VMBR star, then any VLANs must be declared on VMBR star.x and not enostar.x. All right, I'm going to need to change that Possibly in other places too. Anyway, I'm guessing it's root. Okay, cool. So we're in like Flen, as they say. Okay, so enable interface. Generic configuration. Interesting. So I do want to enable DHCP on this. Let's see, system. Why am I getting logged out? I think that's all the pictures of crosswalks. Okay, for some reason, Restream logged me out again. What? Alright, services. DHCP4. Interfaces, opt1. Let's see, LAN. Description. Configuration. Let's go to static IPv4, and then IPv4 address is 10.11.0.1, and this is going to be, okay, fine, that looks right. IPv4 upstream gateway. This is set on auto detect, and that's /24 on this one. Okay, so let's set it to 24 on this one. Alright, save, and then... Oh, whoops, no. This is different, sorry. This one is going to be static as well, but this one's going to be 172.16.1.1. This one is going to be static, and this one is the one that's going to be 10.11.0. Oops, yeah, .0.1. Again, the 24, and then this one is going to be the one that is, so this one is going to be global services. And then opt2 is going to be customer 1. This is going to be customer 2. Also going to be static IP, but this one is going to be 10.11.1.1. Also /24 auto detect. Okay, and so we could make this customer 1, and that would be all right, like that. Okay, so let's take a look at LAN. And what I want to make sure is that when I go back and forth between these interfaces, I want to see that they are essentially the same. That's what I'm looking for. So if I go from LAN to this, okay, can we just apply changes? Okay, so here we go. So, why are these different? What's different between these two? Enable interface, description. This one, yeah, I'm going to go with LAN. Apply changes. Okay, why am I getting different options? Promiscuous mode, dynamic gateway. Overwrite global settings. Okay. So basically, the reason that these two are different, as far as I can tell, is because one of them is a VLAN. Other than that, they're the same. So because global services it knows it's a VLAN, it has this bit about dynamic, or because it doesn't know that LAN is a VLAN, it has this hardware settings bit. Because it thinks it's a full hardware interface. But whereas global services, it knows it's a VLAN, and so it doesn't give it the same options. Okay. I look at the difference between these two. They look exactly the same. And these two look exactly the same, other than the name and the IP address. That's what I'm looking for. Okay. So, assignments. Yep, that looks good. Okay. And then overview. So now, if I go down to services, I'm imagining that now DHCP4, yeah. So now I get all these options. So, global services. Do I want to enable DHCP for that? I don't know. But I do want to enable DHCP for this one. Actually, I don't know if I want to enable that either. Let me think here. I think I just want to spin up another anything and see if it can route through here. I want this to be the router. I want things to be able to get the internet through this. Gateway. Okay, let's check the firewall rules. What I want is for anything on the LAN to be able to contact anything on opt, which I think is the way that it's set up by default, but I don't want anything on opt to be able to contact anything else except opt1. I do. So let me go into rules, and let's see what LAN rules look like. Allow LAN to any. And then WAN. Alright, so LAN is allowed to access anything. That makes perfect sense. So we're going to go to global services, and we're going to add a rule here. Oh, sorry. That's probably really small. Difficult to read. Okay, so let's go ahead and add a rule. And I'm going to open this in another tab because I actually want to inspect what this rule looks like. So the action is pass, and the interface is global services, source, destination. So this looks like a very permissive rule. Basically, the default add rule is entirely permissive. So I want to say that global services has destination, single host or network. So I want to say there can be... Wait, aren't we saying... Okay, so anything on this one can go to anything on 10.0.0.0 slash 8. So this is a LAN in rule. Any protocol, any port range, category, description, allow to any customer. Gateway is default, sure. Okay, so we're going to test this by creating two virtual machines. One of them is going to be on the customer 1 network, and one of them is going to be on the global services network. So customer networks are isolated. This is great. And I wonder, under settings, do we have the ability to export the rules or use an API? OPNsense API. Okay, configuration, backups. Okay, so if this configuration works, then that would be the file that I'd exit, or so we're going to do some copy and paste. So the way that the opt interfaces are set up for customer 1, customer 2, so on and so forth, we're going to pre-generate 100 of those. So, okay, good. Our next thing to do is just going to be to start up another container, and we're going to put one on the global services network, and we're going to put one on customer 1 network. We should really put one on customer 2 network as well. Let me see what I can do here. So create, we'll put this on node 3 to start with. We're going to give this one the ID of 110100. Is that allowed? 0. Zero, 1. Okay, that makes sense. So this is assuming that each customer could have up to 10,000. Okay, that's good. Well, that's how we'll do the IDs. Host name for this is going to be customer 1 001. And this is unprivileged. It doesn't allow nesting. Password. Word. Okay, and then let's get my SSH key in here. And we'll do it on Ceph. It'll be Alpine image. Storage size will be, let's just put it at 2 gigs. CPU, just one CPU. I'm going to put it at 50 out of 100. Memory, 512 is sufficient. Okay, so VLAN setup. This should be on VLAN 1101. We are going to apply firewall rules to this. No, we don't need to apply firewall rules to this, because the firewall rule is being applied by OPNsense. So we don't need to apply any firewall rules. And we are going to go ahead and do a static IP. So I'm going to go ahead and use, what should my test address be? So this is, 17.0.172.17.0.199. If I'm going to do that, oh wait, no, hold on. This is customer. This is customer. So this is going to be a 10.11.0. And then I think we're going to start them at 100. So it couldn't be that many anyway, because it's going to be first subnet, second subnet, third subnet. So let's just call it that. And then this is going to be 99. Let's start it. We'll go from 101 to 99 essentially. Let's start them at 10. The other thing we do, very non-conventional, but we could put the router at 254 and then actually have customer addresses start at 1 and just go up. Anyway, enough thinking about that. So sure, this will be 99 or No, this one will be 10. No, it'll be a 1, and we'll make that 101. /24, and then its gateway will be 101. Wait. So it's actually going to be like that. Too many ones. Let me go double check how I set that up over here. Interfaces. Customer 2. How did I set that up over here? Let me check out something else. Okay, hardware. Okay, that's not the question then. The question is, indeed, how did I set it up right here? In what VLAN did I pick? This one is VLAN 1101, so that should be 1101. There we are. Okay, this one was 1100, so that would be 11.0. Got it. Okay. Sticking with that convention, then we're going to start with (11), 2, 3, 4, 1, 2, 1, 2, 1, 2, 3. Okay. Okay, templates, disk, network, and this will be (1100), so the network will be 1100. Okay, yeah, and the customer address can start wherever. Okay, good. And this is going to be 1100, right? 1100, 1100. Cool. All right, there we go. And then we need to create another one, which I'm going to call this one 170. Zero. 1, 2, 3. All right. So host name is SRV. Whoops! Dang it! I did not mean to hit escape, but I accidentally hit escape. All right. Try that again. 170. 0. 1, 2, 3. So SRV. 1, 2, 3. There we go. No nesting. Password again can be password 1, 2. And then SSH public key is the same. Template Same template, disk, same disk, CPU, same deal, memory, same deal, network, VLAN is 170, and then this one is going to be 172.17.0.199. Okay. Again, /24. No firewall on that either. Okay. All right, so from this first customer here, I'm going to go back and do PCT enter, and this was 1100. Whoops, 1100, 1, 2, 3. And let's see if we can just ping the outside world at all. And it looks like no. All right, so let's look at etc resolve. Okay, apk add vim. Oh, that's not going to work out for us. All right, etc resolve. Name server 172.16.0.1. That might be wrong. Oh. Okay. So this would need to be 11. Well, I guess it shouldn't matter. No, it will matter. It will absolutely matter. Okay, so that needs to be 10.11.0.1. Okay, and then etc network interfaces. Dang it. 10. Customer 001. Okay. Gateway 10.11.0.1. So those firewall rules again. Let's try another rule. Okay, OPNsense allow opt1 to internet. Okay, allow. Why does Restream keep on blocking me? What is going on? Do I have Restream open up in another tab or something? Restream open right there. I don't know. I don't know what's going on. Okay, so where is firewall rule? Customer 1. Pass in direction in. Okay, let me try to read this part again. What is it showing? Okay, it's showing the source is guestnet. Does it show the direction of the rule? Floating, WAN, LAN, guestnet. Okay. Protocol, source, destination. Alright, let's do this first. I'm just going to move this over so I can... Whoops. Where did it go? Ah! I'm moving it over so I can look at it more easily at the same time. Okay. So, here we have this. And we're going to have... I'm going to leave it as the direction. Does it say direction anywhere here? Direction. In or out. Okay, the default is in. Well, maybe let me go look at the firewall rules for the LAN. I could check something else too. Okay, I'll look at the rules for the LAN. No, let me go to firewall, rules, LAN, and then let's see what this is, what this says. In. So coming in to the router. Yeah, that makes sense. Alright, so the rule is for stuff that's coming into the router on interface customer 1, where the source is customer 1 net and the destination is I guess any. Switch from any to any. Okay, too scary. Okay, so I think at this point now I should be able to ping. Okay, I'm going to start up another virtual machine that's going to be on the management network. Or a container, as it were. Okay. 0.0.99. Host name is management 0.99. I can allow nesting. And same SSH key. Same template, same disk size, same CPU, same memory. The network here, it's going to be a 160, and then it is going to be 172.16.0.99/24, and then we're going to make its gateway 1. I'm going to worry about the firewall. And then for the DNS, we're going to use DNS server confirm. Start after created. Yes. And then for this, okay, good. So, good news is this works. I can ping 172.1.6.0.1 and .0. Oops. 2. Okay. And it can ping example.com. Yes. All right, cool. So this one that's set up on the LAN is perfectly working. So basically, I just need to copy. I need to figure out what is this LAN setting and make sure that the. Can I get this to come on? Ah. Oh well. Let's see if I can get these side by side. So to me, these look to be pretty much the same. Just going to try to look at them side by side and see if I notice any differences. So there is, since this is a default rule, it doesn't have a created added date. These look the same. This looks the same. I created a different description for this. All right. Let's go back up. Description, category. Okay, this is all the same. 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 And then this is all the same. This is all the same. This is all the same. All the same. Okay. So in theory, let's make sure that I've got the IP addresses and everything correct and the VLANs. Just double check everything all the way down. So I am logged into, which one is this? Let's do cat Etsy hostname. All right, so this is customer 1. All right, if we look at IPA 10.11, so 10.11.0.1, I should be able to ping it. That should work. If I'm looking at these two side by side and I'm saying these are the rules that we need to follow, if I look at the LAN rule, it's got an IPv6 rule, but other than that, oh, I did not apply the changes. That's why. All right, now let's take a look. Cool. So now, and I could probably even ping crossways. I could probably go ping that. No, I can't. Okay. So it's not doing routing at that level, or what? Again, let's take a look at this one. So okay, can we ping self? Yes. Can we ping internet? Yes. Can we ping... I don't know what else there is to ping, but this is the one that's on the management network. So this one should be able to ping 10.11.0. What was this one? 101? Okay. And then this one, we don't want it to be able to ping that. So then what we do is we create a rule for customer 1 that is a block, or is it a drop or reject? Okay, and then we go interface customer 1 and protocol any blah 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 source any, I guess customer net, anything on customer 1 net is the source. And the destination would be can I oh, this is not going to work as well as I'd hoped. Huh. So block all other customers. All right, then we need a rule that allows source would be customer net. Destination would be single hoster network, which is going to be its own network. Allow customer 1 to customer 1. I'm just going to say allow self. Let me check on chat here. Hey, how's it going, chat? I see you. I see you. Okay. I'm just going to check over here. And this does say source line, not okay. All right. So it's going to be allowed to communicate to itself. It's not going to be allowed to communicate to any other customers. And global services is going to be allowed to communicate to it. Okay, source, customer net 1, destination. It's going to be 192.168.0.0/16. I wonder if this says anything about matching. Date type. Okay. So maybe there should be an allow. I think we want a rule that's basically allow related. What? How would it know any of that information? Okay, let's get out of there. All right, this is going to be block. Okay. So I think I am going to give this a category, which is going to be block private networks. And this one, I'm going to give that same category too. And then I'm going to allow to global services. But actually, before I do that, I'm going to do this one. 172.1, was it 12? No, 1.16, 0.0/12. This one is block. And source is customer net. And destination is single hoster network. And it's this one /12. Okay. I haven't changed the name of this. Alright, so those are all part of a group. Source, customer net 1, destination, single host or network, and this is going to be then 72.1.0.0/24. Oh, and actually I could have chosen this. This actually might have made more sense. Yeah, let's do it that way. And this other one, single host or network. Customer 1 network. Okay. Cool. So allow the customer network to talk to itself, allow it to talk to the global services network, and then allow basically everything else, which is the internet. Okay, so let's see if this works. So now this ping should fail. Excellent. Ping to the router itself should still succeed. Ping to the outside world should work. Cool. All right. That's it. Let's see here. Cool. Cat Etsy host name. Now this guy should still be able to ping 101, no problem. Excellent. Now this is the management network, actually. Right, okay. So that one is not going to have any restrictions. All right, what was our deal on this one here? All right, .199. Let's try that. Okay. So let's go copy some rules. Can I copy these rules? Okay, and then we're going to change the interface to be global services and source to be global services. Alright, we're going to clone this one, but we're going to apply this to global services. Global services. Oh, that's not what we want. Let me go back on that one. Interface is global services. Source is global services. That was pretty much it. Okay. And then we go back to rules for customer 1. And then this whole thing with 192 as well. I'm gonna clone that. Apply it to global services. Apply it to global services again. Then we need to bring these two rules just above that allow. Oh, whoops. Yeah, we're going to delete that rule. Then we're going to firewall rules, customer 1. Whoops. Customer 1. I'm going to clone this one. Global services, save, and apply that one up above this one. Okay, so global services can go to any customer. And first it can go to itself. Then it can go to any customer. And then finally, so allow to internet. Allow itself. Allow to customers. Don't allow to other private addresses. Okay. So let's see if this worked. And I think it will have. And this one will be 1700099. Okay. PCT enter. Alright, so if we ping the internet, we should get access. Good. If we ping the router, we should get access. Good. If we ping the other router, we should not get access. Good. If we ping a customer, we should get access. Okay. 10.11.0.101. Alright, can the customer ping? Oops. How that happened? Customer can ping itself. Customer can ping its router. Customer can ping global services. No. Okay, so something went wrong there. Let's check on that real quick. Let me make sure I've actually got this right. Okay. How do I make this little thing on the side go away? It's taking up valuable real estate. Alright, interfaces, global services. Let's just double check. Ah, that is incorrect. That is the correct address. Okay, now let's try these pings again. Cool, works. Alright, so it can ping global services. Can ping the global services router, yes. But it cannot ping management services. Cool. Alright, so host name. Oops. Let's try this again. There we go. Okay, so customer 101. Ping-C1. I mean, imagine that I don't have another customer up right now, but I'm pretty sure this would work. So, okay, we're just going to run through this one more time. So, it can ping its own, it can ping the internet. Okay, good. It can ping its own router. It can ping the global services network. Oops. And it can't ping the management network. Okay, I think these rules are correct. So we need to make customer 1 mirror customer 2 in terms of the firewall rules. Now let's try cloning this, but we're going to change it to be for customer 2. Anywhere we see customer 1, we're just going to switch to customer 2. Same thing, we're just going to swap it to customer 2. Actually, what are these floating rules? Okay. Oh, okay, cool. Okay, select interfaces. All customers to all services. Okay, so if we do that, then we go to rules and customer one, and then we can get rid of that, I think. Yep. Alright, so this should still be allowed to access global services. Okay, good. And it should still not be allowed to access management. Cool. Alright, well that's neat. So that eliminates one rule that we have to add for everything. So there's customer 1. There's customer 2. So we get rid of that rule. Okay, allow self. Actually, I think we can do a couple more floating rules. Because I can say... Whoops. I didn't actually apply the changes before. I don't know what changes I made, actually. Anyway, we're going to go to block. And we're going to say... If the source is... 10.0.0.0/8 and the destination is 172. Well, first .0.0.0. Oh, no, we can't put that rule there, can we? Block all customer. Okay. Similar. Actually, let me just clone this one. (192.168/16). Oops, and that should have been 12, not 20, but I'll fix that. Okay. Customer 1 doesn't need that block rule anymore. I wonder if is there a way to specify a rule to say let a network have access to itself? I don't think there is. Unfortunately, I don't think that's a possibility, but let's just check and see. But wait, a network shouldn't need access to itself, right? Because it doesn't need... No network needs to go to the router to get access to itself. So that rule is redundant. Or is it? Yeah. That's redundant. Okay, so we don't need to have that rule at all. So we don't need to have that rule because that's at the switch level. Which means that this rule right here, we can edit this to be, well, no, we can't. Okay, floating rule. So here's our floating rules. Any of these sources allow to this destination, block, block, block. Block to all private networks. And again, we can put the category of this. Block private networks. Category of this is block private networks. And the category of this is block private networks. Okay, so all of these are just part of block private networks. So we allow first to global services, then we block private networks. Hold on. Oh. Got a little wedgie action I need to fix real quick. Off camera, you know. There we go. Okay. Well. Let's apply those changes. Let me make sure that the rules on customer 1 are as simple as they can be. Allow customer to any. That's great. And rules on customer 2 are about as simple as can be. All right. So let me screenshot this one. And then I'm going to screenshot this one. And I'm going to screenshot, let's see, rules, global services. Okay, what time is it? Okay, I think all the rules are in effect. All right, so let me start this back from the top. Host name. So customer can get out to the internet. Yes. Customer can get to its own router. Ooh. No. Eh. I guess that's fine. We could do it the other way, but then it would just take more rules. Okay, let me make customer number 2 here, though. No, that's not what I wanted. All right, we're going to create another one of these. This is going to be 11.0.0.0.2. Hostname cust1002. Okay, again, same SSH key. Memory. Network. Alright, no VLAN. Yes, VLAN is 1100. And IP address is 0102. Gateway is 101. Oh, whoops, /24. Start after created. Alright, and then we're going to create another one, which is going to be 1101. Oops, 001. This is going to be customer 2, 001. Same SSH key as before. And then, whoops, it's going to be 10.11.1.101/24. VLAN is going to be 1101. This is going to be C2. Alright, VLAN 1101, 1100, 1100. Alright, so now I should be able to see if I can ping. Customer 1 should be able to ping the customer, its second host. So we should be able to ping 10.11.0.2. Oops, sorry, 102. Excellent, but not 101. Interesting. Not 1.101. PCT enter 1101.001. All right. What went wrong here? 10.11.1.1. Alright, let's check out what happened. Customer 1, customer 1 net to any. Okay. Customer 2, customer 2 net. Oh, whoops. Customer 1 net, clone, customer 2, customer 2. There we go. Apply changes. Excellent. But cannot ping. And cannot ping this. But can ping itself. And then can ping global services. Cool. Yeah, that's great. Okay, I'm going to go back to System and Configuration. And Backups. Download configuration. And then let's share this. Cool. Cool. Well, with that, I think that BNNA is pretty close to ready for launch. I'm pretty happy with this. Do we have floating rules that come after? Okay. Alright, I think I'm done. Oh, sorry, Blah. I did not notice your message come in. Whenever that came in. It doesn't have a timestamp on it. Why doesn't it have a timestamp on it? Oh, 4 minutes ago? Okay, it does. Looks like I was right about TypeScript. People are moving JS doc. I wasn't right about anything. I mean, I did not have any prediction that people would move to JS doc, but that sounds amazing. That'd be great. But I could not claim credit for being right. I was just doing my own thing, and other people happened to start doing the same thing. But I think it's a little... I also think it's a little too late. We need a language that is a browser language that is fully typed, that is a simpler language. And that's what the AI script aimed to be. However, I am about to get off. I accomplished my work for the night. It looks like everything's working fine. One other thing I want to do, though. This would actually make a lot of sense. I'm going to migrate this one to PVE2. What? Oh. I need to go to PVE2 and run this. And then let's make sure that we can still ping, or we still can't ping that. We should be able to ping its neighbor. Yep. Okay, cool. Everything looks good. Now I just need to go, let's see, can I go to HA? Or go to, is HA at the data center level? There we go. I'll create a new group. This is mission critical. Again, priority here would be 100, 500, 500. Okay, we're going to add OPNsense to the group Mission Critical. And requested state is started. X restart 2. I also need, real quick, let's see, network interfaces. I need to redo this on all 3. Okay, I saw more pop up. There is Dart, but people don't want to use. No. We need a browser language. Dart is not a browser language. Dart is a server-side language. They originated as an idea, as a prototype for a browser language, but the problem with Dart is that it is not a language that runs in browsers. Even from its inception, it was a transpile target. I'm talking about something that runs in browsers. See. Okay, so I also need to SH into PVE1, Etsy network interfaces, and then I just got to change it here too. Let me just double check that I did change it correctly. Here at VMBR 0. Okay, good. Etsy network interfaces. I'm not sure I need types doing something small. Well, so you can have a typed language without. So I need to put up my demo for AI script. So AI script, you just write your code as a subset of JavaScript, and the types get filled in automatically. So the typing never gets in the way while you're writing code, and you change a comment from draft to V1 when you want the types to start being enforced. So while it's in draft mode, you just type stuff and it will just tell you, or you write your code and it will tell you what the types are by inferring from the code you wrote. And you can just look and you can say, oh, that doesn't look right. Oh, that shouldn't be null. That shouldn't be a string or a number. It should just be a number. You know, that sort of thing. And so then you could change it to from draft to V1, and then it would show you, okay, on line 7 is where is, and then, you know, updated so it's just number. And well, actually it wouldn't be number, it would be integer, non-zero integer, or signed integer, something like that. Because number isn't sufficient for a type system. But anyway, the point being, you could write your code in a subset of a browser language, a real browser language, an actual browser language, get type information, and then change the doc comment of the type information to have it start enforcing the rules. Okay. Alright. Oh, this one's longer. Why is this one longer? Ah. Because when I was testing this out, I commented it out at first. Oh, there's one extra line down there. Got it. Okay, good. All right, that's fine. Okay, this all looks good then. And so then to the HA group. Let's see, do we have any of this here? All right, so we've only got one group that's mission critical group. Multiple browsers, old browsers used for years. If you want a language implemented by browsers, not going to happen. No, you have to understand what a programming language is, right? You can have a language. There is an infinite number of languages that are already implemented by browsers. Infinite might be a little strong, but yeah, pretty much. So the ECMAScript standard is a huge, huge standard that encompasses several languages in terms of its, if you look at a Venn diagram, ECMAScript has C#, it has Ruby, it has JavaScript, it has its own language of ECMAScript. So if you look at ECMAScript, it doesn't contain all of C#, it doesn't contain all of Ruby, but ECMAScript is a ginormous language. It may be the biggest language out there. And so if you wanted to look at subsets that you can create out of ECMAScript, there's lots of subsets of languages that you can create out of ECMAScript that will run in browsers. So you can certainly have a typed language that will run in browsers. You don't have to change the browser, because one thing that people misunderstand, types don't exist in runtime code. Well, they can sometimes, kind of, sort of. But that's all transparent to the programmer. As a programmer, you don't know what types exist during runtime, generally speaking. Unless you're writing in Zig. Other than that, you don't know. If you or Rust, if you're using Zig or Rust, if you're using Rust, you don't know. You don't know what types exist at runtime. I think Zig is the only language where you could know for certain what types are at runtime. Anyway, essentially, types don't exist at runtime. Types exist at compile time, and so a typed language, when it runs, doesn't have any types. The type information is gone or altered or different. So what you wrote in code is not what runs. And this is the important point on that. Is we can have a typed language where the types exist where they've always existed, which is in the tooling, and the runtime can use the types or not use the types, and it doesn't make a difference. Currently, if your JavaScript is typable, it will get types in the runtime. This is what made, Node really interesting, and V8 before Node. That's why Node was implemented in V8, was because V8 implemented types in JavaScript. They just happen automatically. But as the programmer, you're not aware of that. And so you can, if you write a very nice type system, browsers could optionally use it, but by virtue of the JIT, not by virtue of your doc comments necessarily. If in JavaScript you always treat something as a number, it's going to get optimized. So you get the benefits of typing in terms of optimization in JavaScript by default in any platform pretty much, except for pure interpretive platforms. What you don't get is the tooling, the benefit of the tooling. That's what we need. Even CPU has different commands to add 16-byte int, different floats. But that's all done at the JIT level. That's not something that, even when you're looking at a language like Rust or Go, well, actually, I think in Rust, I think you do always specify the exact size. I don't remember if Rust has int, but Go has int, and C has size T, and those, you don't know what they are. What they are is not important to you. You just write your code, and then when it compiles, the compiler checks your types and gives you feedback on that, as well as your tooling, and then it decides what to do about all those weird sizes and everything. Anyway, everybody's joining in now. Hey everybody, I'm just leaving. GoInt is in 32 bits. You're supposed to know what it will be on your platform. Sure, but that's the thing, is you don't care. It's not important. It's an optimization that the compiler makes. That's my point. If you want it to be, I think you can tell it to be int 32. No, isn't it int 64 by default? Is it int 32? I don't remember. But anyway, the point is, there's different layers of abstraction, and the type system is in the compiler, not in the runtime. But it is time for me to go. Let's see what's happened here. OPNsense. Can I migrate this? I want to migrate this. I just want to see what happens if I migrate it over here. And let's see if I can keep my pings up on... Oops. It might have already migrated. Did it migrate? No, it is migrating. I'd love to see the status on this. There is somewhere that it shows you the migration status, but I don't remember where it is. It's like migrations or something? Metrics. Oh, it's over. I migrated. Oh, look at that. We can tell where it migrated because the ping, it looks like a few pings dropped. Let's see how many packets it says it lost. 25% packet loss. Okay. So it went down for a few seconds. Network traffic was halted for a few seconds. But it just migrated right on across. Pretty neat. Anyway, but for reals this time. I need to go. It's time for me to go to bed. But I am really excited that OPNsense the rules seem to be behaving correctly. Now I got to figure out the XML file and basically make a bunch of copies of the rules. Let me see. Okay, one more thing I'll do real quick. This is just going to be super fast. I'm just going to go into downloads, and we're going to look at config, and we're going to look for 10.0.0. No, let's look for custom one. Okay. Let's look for custom one. Okay, so here's where I might just want to use the API, but here's where essentially we can copy and paste this 100 times. And then we could copy and paste that 100 times. And that's all we need. All right. Well, I'm out. Thanks for the conversation, blah. The rest of you, have a good one. And I'll catch you next time later. Oh, and I don't know why I've not been using, for some reason, I've stopped using the sounds. I guess I've had so few wins. I haven't been using them. But we got a good one. It worked. It worked. That was good. Okay. Good night to you all. Adios.